Alright, so when we have a system of equations in two variables, and one of them has one of the variables that is almost by itself, the best thing to do with this is to begin to solve that second equation for the one variable, because that second one is almost solved for one variable. Okay? Which variable is this one close to being solved for? Y. Y is almost by itself. So I want to take a look at this equation. Solve for y. How am I going to get y alone? Subtract 4x. So we'll do that. And when we solve it for y, we end up with y equals negative 4x plus 9. Now, have I changed the value of the equation at all?
Nope.
No. It's the same thing. Whenever you have an equal sign, as long as you're adding, subtracting, multiplying, or dividing the same thing on both sides, you still have an equal. So I haven't changed anything besides how it looks. Now the purpose to this, the purpose to this is so that I can take this equation and use it with the other equation. Now be very careful. If you don't actually use it with the other equation, you're going to get a false solution. So y equals negative 4x plus 9. And so if I take a look here, there's a y in this equation also.
That's true.
So it is always legal to take something out and replace it with something of equal value.
Is what is in geometry?
It is. Okay? So if it looks familiar from geometry, it is. But we're going to do more in the algebra class than the geometry class, because this is only part 1 of the lesson. Part 2 will be tomorrow. We're going to have lots of practice on these things. So what I need to do is we need to actually replace the y with negative 4x plus 9. So I'm going to take 3x plus 2 times negative 4x plus 9. And if you'll notice, the only thing we did is take that y and replace it with 4x plus 9. And that equals how much?
7.
7. Okay, so we don't want to forget what equation we're actually working with. Does everybody see what just happened?
Yeah, not exactly.
We just plug it in. You took this right here, negative 4x plus 9, and you wrote it in right where the y was, because that's what y equals. Alright? Now, after this, it's just a regular algebra problem that you're used to solving. We have to do what first?
Bring down. What distribute?
Distribute. So we get 3x minus 8x plus 18 equals 7. Then we
combine like terms.
Combine like terms. So 3x minus 8x is
Negative 5x. Negative 5x.
Plus 18 equals 7.
Subtract 18.
Then we subtract 18.
You get negative.
And then you.
So negative 5x equals negative 11. So x is
11 over 5.
X equals 11 over 5.
11 over 5. Am I finished?
Nope.
No, you're not.
No. Remember, when you have two lines that crossed each other, your answer was a what? It was an
ordered pair.
An ordered pair. So this is only half of an ordered pair. So we have to go back and plug it into an equation in order to find the y part. Now the neat thing about substitution is you already have an equation solved for y. So if we take y equals negative 4 times what?
11 over 5.
Times 11 over 5 plus 9. Okay, then we do this, we have negative 11 fifths, or negative 44 fifths, plus 9. So y equals, what is it? 1/5? Does that make sense? 9 times 5, this would be 45 fifths. That makes a lot of sense. So my answer there we go. My answer is going to be an ordered pair. 11 over 5 and 1/5. There we go. That's my answer right here. Answer. Now, why would this be a very difficult